Hello, I'm going to go through the latest entrance exam for MES B in the Netherlands. You can find it on the website, the so-called CCVX website. Scroll down to MES B, where you can see examples of exams. And this is exam 13 here, which is the one held in December 2022, about 2 months ago. They also give a sheet with the so-called uitwerkingen, which gives the solutions, and I will kind of verify what I'm doing here as well. The other material that you need to know is in the so-called syllabus. They call it the syllabus entrance exam MES B, which gives all the required knowledge. It's 22 pages, which you really have to go through and make sure you understand everything there to be successful. So here, the December 2022, total 4 questions. Different from the VWO 6 is that there are no questions that need like numerical analysis or numerical integration. And as a matter of fact, you're not allowed to use a calculator that can do this. But you can use a basic scientific calculator. That can be useful in cases if you kind of forgot what the sign of some basic angles is. You can just verify it here. Of course, it's better to know it by head. So the first question, how much time is there? There's actually 3 hours time. Question 1 is a function with square roots. There's a function f given and a line L, and we need to compute exactly the coordinates of the intersections. So in this case we would need to solve the square root of x plus 4 times the square root of 12 minus x squared equals 4 times the square root of 3. Well, here obviously we can square it, and in this direction we have then that we need to have also that this is to 16 times 3. And you just should note that the reverse is not necessarily true, right? If A is equal to B, then for sure A squared is equal to B squared. But the reverse is not necessarily true. I think this is some of the math skills also listed in the syllabus. Actually, when A squared is equal to B squared, you can also have obviously you can have A equals to B, but also A could be minus B. So if you find a solution of this, you still need to verify that kind of the initial equation here is satisfied. So let's see, just work out what is here. You get let's just start with the highest degree here. You get 4 times minus x squared well, that is not the highest. Oops. Start with you get x times the minus x squared is minus x to the power 3, and then you get minus 4x squared, and then you get the linear terms in x is 12x, and you get a 48, which is good because on the right hand side you also have a 48. So you get minus x cubed minus 4x squared plus 12x 0. So it's a third degree equation, but you can pull out an x, so you get you can pull out a minus x minus, and then you get x squared minus plus 4x minus 12 equals to 0, and that can mean that x is 0, or that quadratic term here is 0, and that means x is 0, or let me see if this can be decomposed. Yeah, you can see this is 2 times 6. So you can write it as x minus 2 x plus 6 equal to 0. So either x is 0, x is 2, or x equals minus 6. And now we have to go back here and substitute each of them. The first x is 0, you get 4 square root of 4 times square root of 12. Yeah, so this is 2, and this is 4 times 3, right? So this is the solution, and for x equal 2, get the square root of 6 minus the square root of 8. And again, it's fine. And then x equals minus 6, that's a problem. You can see this here becomes negative. Actually, both become negative. So we should exclude this. So yeah, then the y coordinate, of course, is the 4 times the square root of 3. So the solutions are 0, 4 times square root of 3, and 0, and x equal to 2. Question 1b. there's a function g given here. It has one maximum, and we need to know the exact coordinates of that maximum. So we just calculate g prime of x and use the rule that if you have two functions, the derivative that are a product, it's just f times g prime plus f prime times g. So that is square root of x plus 2 times, and then we need to use the chain rule, 1/2 times times, we need to subtract 1 from the exponent, so 7 minus x squared to the power minus 1/2, and then times the derivative of what's under the square root sign here, which is minus 2x. And now I take the derivative of the first function. It's 1/2 times x plus 2 to the power minus 1/2, then times the derivative of x is just 1, and then I still need to multiply it by the second function here, which is 7 minus x squared, and we have to set that to 0. Well, let's simplify this a little bit. These 2 here drops, then I get square root of x plus 2. It's a little nasty, but it is what it is. I have some lag in my pen as usual. Times a minus sign and times an x here, plus square root of 7 minus x squared divided by 2 times the square root. It's definitely very easy to make mistakes in these things, so just go slowly, steady and slowly. And that's of the form, if you have something like a divided by b is c divided by d, that just means that AD is equal to BC, but you have to be careful. This is not true when either B or D is 0, which we need to check. So I bring this to the right and I just do this cross multiplication. Then I'll get 2x times x plus 2 has to be equal to 7 minus x squared. So I get a quadratic equation. Bring all this stuff to the left, so I get an x squared. Actually 3x squared, 2x squared, and add this to it. And then I get a 4x, and then minus 7, is 0. Let's see. If I can write this in some form. Need to look at the factors of 7. What about -1 and 7? Got minus 3x plus 7x, 4x. Usually you can factorize it in this way in these problems, unless they want to be really nasty. But this seems to be okay. Just make sure to double check, otherwise you actually waste more time by trying to rush it. Okay, so that means either x equal to 1 or x is a minus 7/3. But it's given there's actually 1. And that's because, going back to the original function, minus 7/3. Then you get, for example, then the x plus 2 will be negative. So this is actually not in the domain. So we just exclude that. And the other thing we need to check is that these are not equal to 0, because the calculation would have been incorrect. But putting in 1 here is safe. So we find x equal to 1. And now we just need to find what is g of 1. That's the square root of 3 times the square root of 7 minus 1, 6 is the square root of 18, which you can just do best the prime factorization of this to simplify it. So it's 2 times 3 squared, so it's 2 times 3 times square root of 2. So the final answer should be 1 and 3 times the square root of 2. Which is correct. Now we go to question 1c. We have these graphs of h, the green one, and k, the red one, and 4.3 is an intersection. And the volume V is the bounded region enclosed by the graphs of h and k. Compute the exact volume of the solid of revolution that is formed by rotating V around the x-axis. So basically, what if you rotate this whole thing around the x-axis, you get a certain volume. It's called omwentelingslichaam in Dutch, and it's part of the materials you need to know on page 10. The volume of a solid with the x-axis as axis of rotation, and you can also have it for the y-axis. So for the x-axis it's generally a little bit simpler. You can just use directly the function if you rotate it around the y-axis, you need to find the inverse of the function. Okay, let's try that. So it is, I thought there should be an absolute value. Well, okay, it's a square. So yeah, so you get the integral from, let's see, well, we also need to find the intersection here. They just give the intersection here. So let's first find that. And it's at the square root of x plus 5 equal to I think it just should be minus 5 probably. Minus x squared. So kind of means that x plus 5 has to be equal to 25 minus x squared, and like in the previous one, not necessarily the reverse is true. So always have to be a little bit careful. And this means x squared plus x minus 20 equal to 0. So x minus 4 x plus 5 equal to 0. We knew already that x is 4 is an intersection. So strange that I give this point, but not this point. But anyway, that that other intersection is minus 5, which is the x here, and 0. So now I need to, and in order to get this volume, we just can take the volume of k and subtract the volume rotated by h. So it's just pi times the integral minus 5 to 4 of k squared 25 minus x squared dx minus pi times the integral of h squared, so x plus 5 dx. So it's pi times, so it's pretty easy to find the primitives of these. So it's 25x. So this will be an x cubed. I need to get 1/3. So I think we write it like this. And here the primitive is 1/2 x squared, the primitive of x, and the primitive of 5 is 5x. And by this bracket notation we mean it's the one evaluated at 4, which is pi times 4 substituted here, so it's 100 minus 1/3 times 4 to the power 3, 64, and then I need to subtract this with minus 5 substituted, so minus 125. and here you get a plus, because minus 5 to the power 3 has a negative sign. 1/3 times 125. And then minus pi, oops, out of space, 4 squared divided by 2 is 8, plus 20 minus a minus 5 squared, 25, so minus 12.5. And this got a minus 25. It's really easy to make mistakes here. So I get pi times 100. $225. And these, let's add these two. 64 plus 125 is 189. And here I get minus pi 28, but this combined is minus 12.5. So it's 28 plus 12.5. It's 40.5. Let's pull out this pi here. 198 divided by 3, guys. What's that? It's divisible by 3, so at least that's good, but okay. I have a calculator here, embarrassing. It's 63, so you get 225 minus 63 is, of course, 162. And minus 40.5. So that is 122, 121.5. Okay, maybe must be some mistake. So yeah, in this video, of course, I have the advantage. I have the okay, yeah, it's actually correct. Anyway, I would still take a little bit more time and double check everything, since you have 3 hours, and this video maybe I want to go a little faster than that. And it's also probably a little bit more neat to put the pi behind here. Question 1D. We have a function qa there. Square root of 16 minus x squared divided by square root of x plus a. Determine the values of a for which the graph qa has an asymptote. Well, so because of the square root of 16 minus x squared, we already know the domain is x from, if you kind of ignore the denominator now, it's from minus 4 to 4. So we don't need to look at horizontal or these like oblique asymptotes, since they concern x going to minus or plus infinity. So what could happen is this denominator can get 0. So when does that happen? Well, this has to be 0. So x has to be equal to minus a. And vice versa. So you would say then that when x is equal to minus a, it has an asymptote, a vertical asymptote, but we need to be a little bit careful. Since this numerator could be 0 as well. But we know it's non-zero. So when x is in minus 4 to 4, excluding minus 4 or 4, then definitely the numerator is not 0. So that basically means that if a is in this range, it has a vertical asymptote in x equals to minus a. Now, so what happens actually when you take the limit to minus 4 or 4? So what if a is 4 or minus 4? Well, in that case, this numerator will reach 0. So we would need to have a look at that. So let's look at this case. Then q, basically that's, I guess q4 is square root of 16 minus x squared divided by square root of x plus 4. Now the limit of this going from the below to 4, I think you in American education you see often 4 minus or something, so something like limit x 4 minus, but I think this is more common in the Netherlands. This limit we know. No, I have to look at since it's minus a, I have to look at x going to minus 4 from the top, from above. So I need to look at this limit. So then both are reaching 0. So you don't really know if this is a vertical asymptote or not, unless we really evaluate this. So, well, this is actually the square root of 4 plus x divided by square root of 4 minus x. So we can just divide out this. Remember, they're not 0. and so you get just the limit of x going to -4 of this, which is well, it's square root of 8. So that's not infinity. So it's not an asymptote. And then you can see from this form the same. You can do the same for a -4. It's so both a and 4 -4 are not asymptotes. So the answer in the end is this this range for a. It will have this asymptote at x equal to -a. Let me see here. Yeah. In this range, it has a vertical asymptote. It's interesting that they didn't evaluate these limits here. I'm not sure if that's actually complete, but okay, I might have spent a little bit more time on it than necessary. Moving now to question 2. A function f is given there, and the region phi is defined as whatever is enclosed by f, the x-axis and the y-axis. And we need to calculate the region phi, the area of that, and so we need to integrate between 0 and whatever the x coordinate is of the intersection of this function. So let's find out what the intersection is. We need to set 9 minus 4e to the power 2x equal to 0, which means e to the power 2x has to be equal to 9 over 4. And taking the logarithm on both sides, it means that log 2x has to be equal to the log 9 over 4, which means that 2x, which is the logarithm of a exponent of an exponential, which is of course the exponent, has to be equal to log 9 over 4, or x equals log, well, 1/2 log 9 over 4. So now we integrate 1/2 log 9 over 4 minus 4e to the power 2x dx, and find the primitive. The primitive of 9 is just 9x, and the primitive of an e exponential function is just equal to itself, but with the chain rule you get a factor 2 when you differentiate, so we need to divide by it. Need to divide this 4 by that, so you get minus 4 over 2. Well, let me just write that as 2 e to the power 2x, and then evaluate it. I think we can reuse these brackets here, between 1/2 log 9 over 4 and 0, which is, we continue here, 9 times this thing, so 4.5 log 9/4 minus 2 times e to the power 2 times 1/2 log 9/4 minus that thing evaluated at 0, which is a 0 here, 9 times 0, minus 2 e to the power 0, which is minus 2. So 4.5 log 9/4. And here what we have, just e to the power log 9/4, which is 9/4. So you get minus 2 times 9/4 plus 2. So that is, let me just do this here. This is minus minus 9/2 plus 2, but 2 is 4/2. So minus 5/2. All right. Okay. So the answer should be, if all is well, minus 5/2. So let's see. 9 log 3/2 minus 5/2. Yeah, actually what they did here, you can use that the log 9/4 is the log of 3/2 squared is 2 times log 3/2. So it's kind of always possible to get some, to rewrite the argument in the logarithm this way. If you would have done that, if you just do that here, you get actually 9 times log 3/2, but this answer is definitely correct. Question 2b. We have the points A and B here, and a line L, which is a tangent to the graph F in point 0,5. And line M is the line through the origin and a point 1,8. So we, okay, cannot draw on this. Well, you have a tangent line here, which will obviously should be some negative number, and then a 0.18, which is somewhere here, so a line that goes up. And we need to find the angle between these two lines. So it will be something like, and I'm very bad at drawing, but you will have one line, say, that will go down, and another line that will sharply go through the origin and 1,8, so something like this. Well, it's a very bad representation. And what you can do is, let's draw a line here. This is the line, I call it line L. is a tangent, and this is line M. And then line L, we can find the slope by calculating the derivative in this point. That gives you this angle here. Let's call it alpha. And we can also calculate the slope of this line going through origin at 1.8. That will give you this angle beta. And that will give you the angle between these lines. And I assume we can just give this this angle. This is just the complement. Okay, so just let's calculate that slope. By calculating the derivative. So we need to want to find f prime in 0, and we get minus 8 e to the power 2x. So e to the power 2x, the differentiation will give you a factor 2, which I multiply by 4 here, and I need to evaluate it at x equal to 0. So that is just minus 8. And that means that alpha is then the inverse tangent of minus 8. So let's move to the calculator for that. That is 8 negative inverse tangent is minus 82.9. Algebraically, if you answer in degrees, well, this can only be approximated, so it's not really clear how accurate it has to be. So just leave it at that. Then what is the slope of that other line? Well, that's actually it actually should be 8, but let me write it out. The delta y divided by delta x. So slope m. Delta y divided by delta x, and the delta y is 8. Delta x is 1, so it is 8. So my beta here is the inverse tangent of 8. But that's of course just the opposite sign, so it's 82.9. Well, so now we know that the angle between these is alpha plus beta is basically these two. This times 2 is 165.7, and etc. etc. Let me check what the answer should be. Yeah, if you have 166, so I guess by when they said they wanted in degrees, they meant in like whole degrees. I have to say that's not very clear. I'm sure this answer will be correct. Well, you might have just add degrees here, just in case people think this is radians. And yeah, the other part is that's good when you have a drawing like this, that you're really looking at this angle and not this angle between the lines. So going to the final part of 2, that's a new function, g, and they tell us there's 2 inflection points. Compute exactly the x coordinates. Well, inflection point means that the second derivative is 0, and basically the derivative has to have an extreme. And actually you also have to show that it's the derivative, say f prime, has an extreme. So it's something like this, but not something like this, if you look at f prime. So let's do that. The derivative of g simply is using the chain rule and using that the derivative of a logarithm of x is 1 over x. So you can, and then using the chain rule and the derivative of the argument here, so you get 2x plus 6 divided by that x squared plus 6x plus 18. And then for the second derivative, gets a little messy. You need to take the derivative of that again, and you use that a derivative of a quotient. This is part of the materials, is g times f prime minus g prime f divided by g squared. So this is x squared plus 6x plus 18 times 2 minus the derivative of the denominator, 2x plus 6 times the numerator, 2x plus 6, and divide this whole thing by the same here, and this has to be equal to 0. And so let's just look at all the quadratic terms. So you get 2x squared, and here you get minus 4x squared, so you get minus 2x squared. And then let's look at the linear terms, 12x and minus 12x, minus 12x, so it's minus 12x total. And 36 minus 6 times 6 is 0 actually, so that's not bad. Has to be equal to 0. And that means this numerator has to be 0, assuming that the denominator is not 0, which we have to check to be precise. So I can pull out minus 2x times x plus 6 is equal to 0, and that means x equal to 0 or x is equal to minus 6. And the only thing now we have to check first that this denominator is not 0, but to substitute 0 here and minus 6, you get 36 minus 30 plus 18, so it's all fine. And you also have to show that it's an extreme, meaning that and for the derivative to have an extreme, it means that the second derivative is changing sign. So it's going up, say, to the left and down to the right, or down on the left and up to the right. And well, looking here at the expression for the second derivative, around 0, around 0 it will change sign, and around minus 6 it will change sign. So indeed this derivative will have an extreme, and these are two inflection points and with the x coordinates. And I guess maybe you have to show just a little bit better that this indeed is changing sign, so that it's an extreme. So here it is, x is 0, x is minus 6. They don't say anything about proving that these points are extremes, or the derivatives there is an extreme. So maybe this is maybe just good enough. But to be rigorous, that is definitely necessary. Moving to question 3 about trigonomic functions and tangent lines. Okay. We have a function f given here and a point a if x coordinate 1/6 of pi, which is on the graph f, and then use exact computation to find an equation for the tangent line to the graph of f in point A. So we need to find the coordinates of point A, and we need to find the derivative of this line by calculating the derivative of f in this point. So let's first find the derivative. You can probably use one of the trigonomic equations that are actually given in the exam sheet to write this as as something like the sign of double the x, and that will make it a little bit simpler form, but we don't need to do that. We can also just use the product rule for differentiation. So we get 4 times the sine of x times the derivative of the cosine, which is the minus sine of x. And remember, the cosine will go down first if you go to the right from 0. And then plus 4 times the derivative of the sine, which is a cosine, times the cosine of x. So that's minus 4 sine squared of x plus 4 times the cosine square of x. So what you can do here is for example, you can leave it here and just substitute actually, or you can simplify this a little bit by using that this is 1 minus the sine square. Actually let me do that. It doesn't matter. So we can, for example, write this as 1 minus cosine square x plus 4 times the cosine square x. So you could here 4 cosine square x plus 4 cosine square x is 8 cosine squared x and minus 4. And now we can substitute 1/6 of pi, and these are the angles that you just need to remember. You can draw a unit circle if you want. So 1 of 6 pi, pi is 180 degrees, so this is 30 degrees, so it's like somewhere here, and this here is 1/2 square root of 3. So you need to remember this. You need to remember the 45 degrees, 60 degrees as well. So this is 8 times 1/2 square root of 3 squared minus 4. It's 8 times 1/4 times 3 minus 4 is, this is 2 times 3 is 6, minus 4 is 2. So the slope is 2. And what are the coordinates? So what is f of 1/6 pi? So it's 4 times, so the sine here is 1/2. 4 times 1/2 times, again, the cosine. So that is the square root of 3. Okay, so we know the line has to have the form y is 2x plus the y-intercept, and now we need to find what b is, so we substitute point a in it. So square root of 3 has to be 2 times 1/6 pi plus b. So b has to be equal to square root of 3 minus 1/3 pi. So I finally find the expression of the line is y is 2x plus square root of 3 minus 1/3 pi. That is also the answer here. Okay, next. Use, okay, they give an antiderivative of f, it's cosine 2x, and use computation to show this. On this case we just need to show that if I take the derivative of this, I find the original function. So, well, what's f prime of the capital F? That's using the chain rule, the derivative of cosine x is minus sine x. So you get e minus sine of 2x, and then with the chain rule times, I need to take the derivative of the inner function here, which is 2. So I find 4 sine 2x, and now I can use that that equation we saw earlier, that the sine of 2 times the sine of 2x is the same as the cosine x times the sine x. Got it wrong. No, this doesn't make sense. Basically this is a special application of this equation here, the first equation of a sum of angles. And in this case just t is equal to u. And basically what you have to, if you just remember this equation, the sine t plus u, you can find, and you need to know the cosine t plus u is this, the third equation, then you can derive most of the other equations here. Okay, so we get that this is another mistake. Okay, well, this has to be a 2, of course. Otherwise I wouldn't have gotten the answer. So that's how I found out. But now I substitute this in here, and I get f prime of x is 4 cosine x sine x, which was the original function. So I've shown that indeed this is the antiderivative. Okay, so now they have a point B with x coordinates quarter pi, and they state that's also on the graph F. and then L is the line through the origin at this point P, and then phi is kind of the region enclosed by this line and the function. We need to find the area. So what we need to do is calculate the integral from 0 to pi over 4 of our function cosine x, and then minus the expression of this line. Actually, yeah, I should first find out what this line is here. And for that I need to know the y-coordinate of B. And actually this is what I call direct relation. The y-intercept of this line is 0. So it's pretty easy to find that. So what is, let me do it here, what is f at pi over 4? Well, I need to substitute that. That's 4 times the sine of quarter over 4, which is 1/2 square root of 2. And the cosine is actually the same. Again, go back to your unit circle to find that. It's one of the angles you need to know. If push comes to shove, you can still check it in your calculator, since the calculator is allowed. You can put it in radians, enter quarter pi. Anyway, I don't think you need to do this. Then find the sine, and then you find 0.7, which you then need to recognize as the half the square root of 2. Again, try to remember these standard angles as I mentioned just now. So this is, these all drop, so you get 2. So that line there is the slope. This is the slope of the line. Let me see. So what we do here is wait, this is not the slope of the line, this is the y-coordinate of the line. So if you want to know the slope of the line, you can take the derivative here, but you basically can see that you go a quarter pi here, go up by 2. You see this is the line here. So the slope is 2 divided by a quarter pi, dividing by a quarter is multiplying by its reciprocal. So this is 8 divided by pi. That's the slope of the line, and since it's a direct relation, the line is just y equals 8 over pi x. So that is what we have here then. 8 over pi x. Yeah, dx. So let me continue this here. So they already are nice enough to let us calculate what the primitive is of this function, namely minus cosine 2x. So I just substitute that. I get a minus 2 cosine 2x minus 8 over pi x, and then we need to evaluate that between quarter over pi and 0. This should be actually a positive number, but let's see. So I get minus cosine minus cosine of a quarter pi of half. Let me just first write it out. Minus 8 divided by pi times a quarter is minus 2. And very easy to make mistakes here. And then this thing evaluated at 0, the cosine of 0 is 1. So this gives us a 1, a negative 1. And this is 0, so it's this. And that is equal to, so cosine of half pi is 90 degrees. So it's actually 0. So you get, this doesn't make sense. I must have made a mistake. This is, I get a negative number, minus 1. What did I do wrong? Well, I did something wrong. I need some debugging. So the point A, or the point B is f at quarter pi, 4 times sine cosine is 2. So this should be the slope. Should be correct. This should be correct. Then the primitive was given minus. Okay. I did make a mistake. This actually should be x squared and a half. So this becomes a 4. So if I take the derivative of this, I should get this here. So this is all wrong. Well, I'm very lucky. I got a nonsense result, minus 1. Otherwise, if this happens to be positive, probably I just left the answer and I would have some great deduction here. So goes to show. So I need to correct all this. But if you have sufficient time in the 3 hours, you just have to go line by line through everything. Okay, so I get 4 over pi times a quarter pi squared here. And well, minus this, the cosine term will still be 0. Sorry, the cosine term will still be -1. And substituting 0 here, we still get 0. So it's this. Well, so the cosine of half pi again is 0. So I get 0 here, and I get 1 over 16. So I get 4 over 16, which is a quarter, minus a quarter. And I get a pi squared divided by pi, and then plus 1. So it is a 1, and then minus a quarter pi, which is a positive number, and should be correct then. Yeah, that's the correct. Okay, goes to show I wouldn't have full grades for this exam probably. Okay, question D. For x in the interval 0 to 2 pi, we have a function g given here, and we need to compute the coordinates of the points on g where this function has a extreme value, minimum or maximum. So we need to find out where the derivative of that function is 0. So g prime of x is, using the chain rule, well, the derivative of a sine is a cosine, so you get the cosine of pi times cosine of x times the derivative of the inner function pi times cosine x, which is pi times minus the sine of x. So this is combined minus pi times cosine pi cosine x times sine x. So this is 0, and either the first, this term is 0, or the second term is 0. So you can just say that g prime x is 0 when the cosine of pi times cosine of x is 0, or the sine of x is 0. So let's look at the first. That happens when, well, let's first look at when, say, the cosine of this, let's rename this u, is 0, means that, and we can draw a unit circle here. The cosines are 0 at these angles here. So it means that u is either half pi plus actually any number of any integer number of pi's added to it. So I can go pi, another pi, and etc. And you can just also draw the cosine function and easily verify that. So that means that we need to have pi times the cosine of x has to be 1/2 pi plus k pi. Again, k any integer. And I can divide out pi, so it means that cosine x has to be equal to 1/2 plus k. Now we know that the cosine of x is always between -1 and 1. So k, well, k can be 0, which means the cosine of x has to be 1/2. Or k, well, if k is 1, that can never happen, there's no x. K2, 3 also not, but negative side -1, k is -1, we have cosine of x is -1/2. That's also possible. Then -2 here, again, it's not possible outside the range of cosine. So when is the cosine of x 1/2? Well, again, need to know our trigonometry here. So that happens at pi over 3 here. And it also can happen here. So that's basically 2 pi minus pi over 3. So this is x is 1 over 3 pi, or x is 2 pi minus 1 over 3 pi. This is 6 over 3. That's 5 over 3 pi. And when is it -1/2? Well, it's right here or right here. So this is basically, this is pi. So it's pi minus a third pi is 2/3 pi, or pi plus or pi plus 1/3 pi is 1 1/3 pi. So that's for 1, and for 2 here the sine of x is 0. Well, when does that happen? Obviously at, so this, the sine is projection on the y-axis, so that happens at sine x is 0, and within this interval that happens when x equals to 0 or x is equal to a pi or x is equal to 2 pi. Let's see if that so 1/3 pi, one and 2/3. That's this one. Two-thirds pi and 1 and 1/3 pi. So that's correct, and then 0 pi and 2 pi. And actually you need to, they're asking for the coordinates, so we also need to find the y values of that. So for this, if the cosine of x is 1/2, or let's start, yeah, the cosine of x is 1/2, then the y value is so cosine x is 1/2, so you get the sine of 1/2 pi, so the y is 1. And if the cosine of x is minus 1/2, you get sine of minus 1/2 pi, which is here, which is minus 1. Y is minus 1. And sine of x, if the sine of x is 0, that means the cosine of x so if x is 0, just substitute x is 0, you get the cosine of 0 is 1. So you get the sine of pi, which is 0. So here y is 0. And here where x is pi, you get a cosine of pi, which is minus 1. So you get the sine of minus pi, which is also 0. And when x is 2 pi, you get a cosine of 2 pi, which is 0, which is 1. So again you get the sine of pi, which is 0. So yeah, I guess you can just then write out all the coordinates to be complete, but I think this is probably good enough. Moving on to question 4, circles, lines and a triangle. So we have a circle given here. And a line M with a vector representation. And shown here. Then they say two lines that are parallel to the x-axis and having a distance of 2 to circle C1 intersect this line M in A and B and compute the distance between A and B. Basically we need to calculate A and B and then calculate the distance. So let's make a sketch. Roughly like this. It's pretty difficult to write straight lines, but so here we have something to center, and there's then this horizontal line with distance 2. So here and here, and this distance here has to be, so how you define the distance from a circle to a line is actually defined in the materials under geometry in circles. Computing the distance between a line and a circle using the perpendicular line from the center of the circle to the line. So this is the perpendicular line, and well, this is the radius, which is the square root of 25. That's also something you need to know. So the radius is 5. That means this has to be 2. And this again is 5 and 2. But what is the y coordinate here? That's -1. So the center here, the circle, is 3 minus 1. So the line, that first line, say line 1 is basically y is equal to -1 plus 5 is 4 plus 2, y is equal to 6. That's, so this line is y6, and the line 2 here, I have to go 5 down from -1, it's -6. That's y is -8. Now we need to intersect this line with this line M. So what we can do is write this line 1 and 2 also in a vector representation. Well, since it's a horizontal line, the how do you call this, the Dutch the richtingsvector will be, because it's horizontal, will be 1, 0. So the expression of line 1 will be, well, we first can take an arbitrary point on the line, so this, and then plus, say, unit vector to the right. So the expression will be 0, 6, it's the coordinates of this point, plus, say, a mu, and then 1, 0, which is the richtingsvector. I think I forgot the English name, pointing vector, or a directional vector probably. And then line 2, well, this point here is 0, -8, and then this directional vector is the same, 1, 0. So let's first intersect this with M. So we just need to set 0, 6 plus mu10 is equal to -1 minus 4 plus lambda 3, 4. So that leads to mu equals -1 plus 3 lambda, and 6 equals -4 plus 4 lambda. So we can basically most easily just find it from here. You get lambda is 10 divided by 4. So, and then we need to substitute lambda. Then we get the intersection. Get a little bit out of space here. You get -1 plus 3 times 10 over 4, and -4 plus 4 times 10 over 4. Which is this is 30 divided by 4 minus 4 over 4, so it's 26 over 4. And this is -4 plus 10. Well, of course this has to be 6 because the line is y is equal to 6. So 24 over 6. 13 over 2, 6. Okay, then we do the same with the second line. So I then get the, so this is line 1, line 2. I get mu -1. That's basically the same equation. Then -8 equals -4 plus 4 lambda. So lambda is -4 divided by 4, so lambda is equal to -1. And then we get, so for the coordinates we get -1, -3, so -4. And this has to be -8. So that's our point B. This is our point A, this is our point B. Now the distance then, okay, delta is the square root of 13 over 2 minus minus negative 4 squared plus 6 minus negative 8 squared, and the square root of this whole thing. Okay. Oh, what's this here? 13 over 2 plus 4 is, I'll write this as 8 over 2. It's 21 over 2 squared. 21 over 2. So the 21 over 2 squared plus 14 squared, and then the square root. So that is okay, embarrassing, but just still plug it in. 21 squared, 441. 441 divided by 4 plus 168, I think. 196. Oops. Square root of this. Okay, so put this under the same denominator. It's 4 times 196 plus 441 is, I hope this goes well, divided by 4. Well, let's see, maybe this has actually a square root. 35. That's good. So this is 35, and the square root of 4 is 2. So 35 divided by 2 is 17 and a half. Let's see. Okay, 35 divided by 2. So that's correct. Question 4b. There are 2 points on the circle at which the tangent lines to C are parallel to the line M. Compute exactly the coordinates of these 2 points. Well, that's, so where are we? Question 4b. Let's draw the circle again. Okay, the center is here. So for a line to be tangent and parallel to this line M, so let's say line M is here, and we will be looking at a line here, and then the points on the circle on this line are here, and then here. So yeah, I think there's in the material a tangent line, point of tangency. A tangent line to a circle is perpendicular to the radius to the point of tangency. Oh yeah, this is called the point of tangency. So we'll be looking at this perpendicular line here, perpendicular to the line M, which has to go through the center. So if we can find the expression, what we have to do is find the expression of this line here. Let's call this L, and where it intersects with the circle. Basically, these are the points of tangency. But how to find this line L? Well, we know two things about it. First, it has to be perpendicular to line M. So here this angle is 90 degrees. And it has to go through the center of the circle. And I think we can easily do that with the vector representation. The directional vector of the line is 3, 4. So now let's find a vector that's perpendicular to 3, 4. Well, you do that just by flipping the x and y and put a negative sign to one of the coordinates. So there will be a minus 3, 3. And the reason is that if you do the inner product of these two, you get 0. So you get 3 times minus 4 plus 4 times 3. And that's also part of the let me see. A normal vector of a line is a vector perpendicular to the direction vector of the line. So line L, the direction vector PQ, has a normal vector Q minus P. And you can just easily see that, noting that the inner product, if you do this, is 0, which means the cosine has to be 0, which means the angle is 90 degrees. So we know the directional vector, or it is called direction vector, that's the right name. Okay, direction vector. But we also know that the circle center has to be on it, and that the center of the circle is 3 minus 1 again. So our line L is 3, that's a 3 minus 1 plus lambda minus 4, 3. Okay, and now we just need to intersect it with the circle, and we do this by substituting this in the expression of the circle. And obviously we should get two solutions. Oh, let's see that. So we get 3 minus 4 lambda minus 3 squared plus 3 lambda minus 1 plus 1 squared. Lambda minus 1 plus 1 has to be equal to 25. Okay, so these things drop actually. That's because this position factor is exactly the radius. So you get 16 lambda squared plus 9 lambda squared equals 25. Well, actually lambda squared has to be equal to 1. So lambda is plus or minus 1. Okay, that turns out to be pretty convenient. So that means point 1 will be uh, 3 minus 4 minus 1 plus 3 is minus 1, 2. And point 2 will be, well, I can just do it right away, 7 and minus 1 minus 3, 7 minus 4. Okay, so these are the right answers then. Question C. A line with equation y is p intersects the given line M here in a point N, such that N is the center of a circle C2 with radius 8 times square root of 2, which passes through the origin 0, 0. So let's try to draw this. We have a line M and say we have a line y equal to p. And then this is point N. And point N is the center of a circle C2 with radius 8 with this radius which passes through the origin. So it means that, well, there's this circle C2 somewhere here. But it means that the distance of N to the origin is 8 times the square root of 2. So let's say N is, let's say the coordinates of N is AB. Actually, we can say we can just call this P. This is the y coordinate of N. we know two things of this, and namely that the distance to the origin is given here, and it also is on line M. So the first condition means that the a squared plus b squared has to be equal to the square of this. 64 times 2, 128. And we know it's on the line 2, so we can write A and B in this form. So A is a certain lambda minus 1 plus 3 lambda B is minus 4 plus 4 lambda for a certain lambda. Actually, this, for that lambda, this has to be P. So we can substitute this into the first condition. So we get minus 1 plus 3 lambda squared plus minus 4 plus 4 lambda squared is 128. So let's look at all the quadratic terms. So it's 9 lambda squared plus 16 lambda squared, so it's 25 lambda squared. And let's look at the terms linear lambda. So it's minus 3 lambda minus 6 lambda from here, and minus 16 minus 32 lambda, and we have the other terms here, the 1 squared, the minus 1 squared, which is 1, and the minus 4 squared, which is 16. It's 128. So we get 25 lambda squared minus 38 lambda plus 17 minus 128. So minus 111 is 0. Is that all correct? 17. Third 25 lambda squared. Well, it is a little messy, but just double checking. This is the line M, substituted here. 1 squared, 4 squared, minus 6 lambda minus 16 times 2 minus 32. Okay, I think we just need to use this equation to solve quadratic equations. I think it's listed somewhere as required knowledge. Let me check. Solving equations, quadratic Okay, I cannot see here they give the equation, but it's definitely something you have to fall back to if you cannot easily factorize it. Oh, it's x is minus b plus or minus the square root of b squared minus 4ac divided by 2a. Alright, so I got x is, well, b is minus 38. I got 38 plus or minus the square root of 38 squared minus 4 times 25 times minus 111. Alright, the grinding is real. Divided by 2 times 25. So 38 squared. And this is just a plus sign, a plus 4 times 25 times 111. And the square root. Well, fortunately that's a nice number. So it's 38 plus or minus 112 divided by 50. So either x is, okay, embarrassing to use calculator for this, but so it's either 74 divided by 50 or x is 150 divided by 50, which is 3. Oh, well, I used, so this is actually lambda. Okay, what are we going to do? Yeah, now I just need to substitute the lambda here into this equation for p to find the values for p. So yeah, there are actually two values possible for p. Where the distance, sorry, this is negative, because you can have the situation that there's a line here somewhere that also has that distance. So so we also there's another y is p possible here when p is negative, likely. So substitute this, I get p is minus 4 plus 4 times negative 74 divided by 50 is minus 4 plus 4 times 74 is 296. I guess you can simplify this ratio a little bit better. This has to be negative. But let's just put this under the 50 denominator first. And minus 4. Yeah, should be right. So I can I write this as minus 200 divided by 50. So I get 200 minus. It's minus 96 divided by 50. And I guess you can divide it by, at least you can divide it by 2. I think this is probably as far as you can simplify it, given that this is 5 squared, and we cannot divide this by 5. So let's say our P1, and then our P2 is simpler. That is just minus 4 plus 4 times 3 is 8. And if all is well, actually it's not correct. They have lambda minus yeah, I must have, yeah, this is incorrect. Let's do this again. Okay, this should be minus 200, negative 200 minus 296. I'm not sure, somehow I missed something here. Is minus 248 divided by 50 divided by 25. My God. Okay, that's what you get in question 4, which is what they have here. So see, I made another mistake. So definitely, probably in the if I would do this exam, I would have chance to go through this all again. But still, final question 4D. We have point P and Q on the circle C1 with equation, yeah, that's of course the same equation. And with another point on the circle such that the angle PQR is 30 degrees. Compute the length of side PQ. The length of side PQ. Well, that will just be the distance between these points. And then the angle QPR. So let's try to draw it. And try roughly, never mind the curves in my lines here. Something like this. So P is 0, 3, so that must be here. And Q is 6 minus 5. And this is X is 3, so it's probably somewhere here. Q. And there's a point R such that the angle PQR is 30. So Q is in the middle. So let's say we have this side, that's PQ, and then the R is, there's an angle like either 30 degrees this way or this way. Let's draw it here. So R is something like this. And then we have this triangle. I guess it can also be something like this. Say R2. And this angle is 30 degrees. Well, not sure. Let's first do part 1. We can just immediately calculate, so the D, at least that part is easy, is, let's say, 0 minus 6 squared plus 3 minus negative 5 squared, and then the square root is 6 squared plus 8 squared is square root of 36 plus 64. Oh, so square root of 100, that's 10. So this is 10. And the angle of QPR. So what's this angle here? That's the question. We know this angle, we don't know this angle and this angle. Well, actually the radius of this circle is 5. And this distance from P to Q is 10. So actually that means, so since the distance is twice the diameter, it means that PQ has to be so-called diameter of the circle. Or basically it goes through the center of the circle. And there's some material you need to know about triangles and circles here. First, they talk about the circumscribed circle of a triangle. That is actually the case here. This is a so-called circumscribed circle of this triangle PRQ. And there is say that the center is the bisector. The center is the intersection of the line segment bisectors of the sides. But that's not, I don't think that's useful here. Okay, here it is this Thales theorem. One of the sides of a triangle is a diameter of the circumscribed circle, which is the case here, namely PQ. The opposite angle is a right triangle. So they're saying that this angle here is actually 90. And that means that we actually can know this angle here, because then the angle, what was the angle QPR, given that the sum of these angles has to be 180, it's just 180 minus 30 minus 90 is 60 degrees. So that is actually interesting that, yeah, well, a little bit of a tricky question, since you have to kind of find out that PQ is a diameter first, so that you can apply this. Then they also talk about the inscribed circle of a triangle has all three sides as tangent lines. So you can just show that, let's say I have a triangle and I can define an inscribed circle, and that let's draw the bisector. The bisectors of an angle are just cutting the angle into equal parts, and the inscribed circle will go sort of here. So it's different from the circumscribed circle. It's something like this, and that other one is saying that these sides are all tensions to the circle, and that's for all the sides. Anyway, that is not related to this question. I think we done then. Let's see actually. Yeah, 10 is twice the radius, so PQ is a diameter. Okay, well that was a little bit of a tough question, I guess, but only 4 points. And I think the first part at least should be easy enough. Alright, that's it.